All right, so it's about 2 after, so let's get started, and hopefully people will be slowly trickling in for the next couple of minutes. So my name is Predjag Klasnja. I'm an associate professor at University of Michigan and one of the core faculty for the Training Institute. And Vivek kindly asked me to coordinate today's session, so I'll be doing the transitions and introducing speakers and so on today. And so last time you guys met, you had a set of talks that were all around sort of understanding health behavior and various ways of thinking about how our frameworks and theories for health behavior can be used to create interventions. Today, with a set of talks today, we're going to be slowly moving towards a more methodological focus. And so I'll be starting us off with just giving you a sense of sort of what kind of trade-offs you can be expecting as you're thinking about the platform that you will be choosing for your mobile health research. Kjell de Hoy, who joined us here, is going to be speaking after that on the use of network analysis in mobile health research. And then this afternoon, we'll have 2 talks, one by Walter Dempsey, who is the statistician here at Michigan, who is going to be talking about data missingness in mobile health research. And then Eric Eckler from UCSD is going to finish us off today with a talk about how to sort of think about involving communities in mobile health research in a way that still allows us to make some claims about what are the underpinnings of the causal processes that happen in the interventions that we create. So a relatively diverse set of talks that sort of give you a relatively broad sense of the various kinds of broad methodological issues that take place in mHealth. And then starting next week, or is it next week, or whenever we start actually meeting in person in July, there's going to be a lot more methodology. So Billy Nakonshani is going to be speaking about the experimental design. Susan Murphy is going to be here to talk about macro-randomized trials. And so you'll get a lot more methods coming up. The one thing before we start, though, that Vivek asked me to remind you of is that you'll be getting surveys for feedback. Please complete those. And also, before the next sandbox, the first sandbox session, which happens next Monday, he really wanted me to emphasize that you want to have seen all of the pre-recorded talks by that time, so you have the grounding in that before we get moving on actual team projects. So those were the only 2 pieces of housekeeping that I was asked to present. Any issues or questions on your side before we get moving? Nope. All right. In that case, let's talk about what kind of technologies you can use for mobile health research, and then we'll move on. We'll have a little bit of a 15-minute break, and then Kjell will pick up on with network analysis issues. So let me share my screen, and I'll get us started. Feel free, by the way, I'm totally fine if anyone wants to interrupt at any point. It's hard for me to monitor chat while I'm speaking because I'm just on a laptop screen, so I'm not able to see chat questions. So feel free to unmute yourself and ask questions if at any point while I speak, or you can sort of hold on to it until the end. I'm fine either way. All right, so let's see where we are here. Everyone able to see that? All right, awesome. Okay, so really the purpose of this talk, and I used to give talks about user-centered design, which is one of the topics for which now we have a pre-recorded talk here at the Mobile Health Institute. But a couple of years ago, Vivek asked me to sort of switch to what I speak to scholars about based on at this point, over 15 years of experience that I've had about building various kinds of platforms for doing mobile health research and all the words that come up with that. So I'm going to give you a sort of a sense of what the lay of the land is for what kind of choices you can make in terms of mobile health research platforms and what the trade-offs are of each. And so just to get us started, one thing that is important to understand is that all of this, whatever you choose, it's always a compromise. Bill Buxton, who is one of the preeminent interaction designers previous to the University of Toronto, he is now at Microsoft Research, said that all design is compromised. And that is equally the case for infrastructure. Any platform that you end up choosing, and that's important to know upfront, is going to have trade-offs. And the question is just, what kind of trade-offs can you live with? So what I'm going to give you a sense of today is sort of the various kinds of options that you might want to consider when you're choosing a platform for doing your mobile health studies. including just using completely off-the-shelf tools, so commercial software and hardware, various kinds of white label solutions, hybrid systems where you're sort of mixing and matching some custom code that you yourself write or your group writes with other sort of commercial systems, and then doing everything completely from scratch as a custom system, and then various kinds of decision-making considerations that you might want to make when you're trying to make this decision. So just at the very broad level, one way to think about this is that you sort of need to make choices about what kind of software you use and what kind of hardware you're going to use for your study. And on the software side, really the options are to either go with systems that already exist that are completely commercial software. So we're talking about things like Fitbit or Insight Timer or any of these. There are many health applications that are available. A lot of them that have APIs that you can use to download data, right? And so it's possible to actually go completely commercial. Various kinds of white label solutions, which are basically platforms that are developed by firms that are intended to support research, right? So things like Fitabase or Care Evolution. I will be speaking more about that in just a second. Hybrid systems where you select some components that are readily available, either as commercial or white label solutions, and then you add to that your own custom code. And finally, sort of building either a full platform or just an intervention from scratch as part of your research. On the hardware side, there's similar kinds of considerations, although those tend to be, for most studies, more constrained, right? So you have smartphones and smartwatches that are clearly commercial. You have all kinds of commercial sensing devices like activity trackers and glucometers and blood pressure cuffs and so on. But also in some mobile health studies, that have a larger engineering focus in terms of where the science is, you might decide to use custom sensors. So sensors that engineers on your projects are building, and to use those. And then, of course, you can sort of mix and match again, right? Where you can, some of the sensors that they use are commercial, others are going to be more custom and so on. And so in any given study, you can sort of make choices that are a combination of on both software and hardware side of these more sort of ready-made solutions that already exist and things that you yourself develop. So what does this end up looking like? Well, on the commercial side, this is often done both you can use some commercial software both for intervention and for assessment, right? On the intervention side, there are a number of health applications like Fitbit and Garmin, like Insight Timer, like Headspace, where they're already sort of science-based or state-of-the-science interventions that contain many of the intervention components that you might need for your project. And so it might make sense to actually just use a tool like that to deliver the interventions. On the more assessment side, things like Qualtrics are a prime example of something that is now pretty powerful and allows you to do really pretty sophisticated work on the mobile health side without ever writing a single line of code, right? And so what does this end up looking like in terms of actual studies? So I'm going to give you a couple of examples. One is a study that a colleague from UK of mine called Petr Slovak has recently done, where he ran a trial of an intervention that was intended to help children with emotional self-regulation, right? And this particular study was done completely with off-the-shelf tools, right? So he, in his previous research, has developed a little instrumented toy called Perils that has since then been commercialized. And now you can just sort of go to Amazon and pick up one of these things for about $50 that is intended to help children sort of soothe themselves. So the toy will breathe really rapidly until a child starts patting it, in which case the toy will calm down. And the idea is that they will the toy allows the child to co-regulate and calm their own emotions. And so what Petr did is he basically was trying to see, okay, if you give children this kind of a toy with some narrative around it, sort of how they should be taking care of the toy, of this creature that was found abandoned, and what kind of care the creature needs. and then he was providing parents with nightly surveys using Qualtrics, completely off-the-shelf tools, that sort of asked about how the child is doing, what kind of conversations they were having about self-regulation and so on, as well as then sort of doing those assessments on clinical outcomes on a weekly level, again, completely through Qualtrics. And he found really impressive reductions in sort of distress symptomology used in the study. Again, without really building any custom code at all. And so, you know, a commercial toy and Qualtrics that were the only tools that were used here. Similarly, there was a weight loss intervention that David Arterburn at Kaiser Permanente, Washington, did recently, where he was trying to combine mindfulness-based approaches to weight loss with sort of more standard cognitive behavioral therapy. And what they did here is that they combined several commercial products. One is the MyFitnessPal, which was being used for diet monitoring. So it was basically a log just for tracking diet. They combined that with an application called Eat Right Now, which was developed by Judd Brewer, Coizet Brown, but has been commercialized since, which provides training in mindful eating. Basically, the idea is to help individuals over the course of 12 weeks acquire skills for paying attention to how they're eating and how their body is feeling as they're eating. And then finally, there was cognitive behavioral coaching that was done through this commercial platform called Coachific that David and his collaborators were using. And so again, it was sort of a combination of three commercial systems that were integrated into a single intervention that was then piloted with patients at Kaiser Permanente. And so what these kinds of approaches have in common in terms of the advantages is that since you're relying on commercial software, the actual software and hardware, insofar as you're using sensors, so commercial sensors, are going to be reasonably polished and usable, right? Companies spend a lot of money on making these products good because engagement is one of the key things that they're trying to optimize for. And so you're not dealing often with any kind of egregious bugs in terms of user interface and usability, because all of the stuff has been taken out by the commercial company that produces it. They also tend to be professionally maintained, right? So all of these companies tend to have large teams of programmers that can fix bugs and make regular changes to the system to keep up with the changes in the operating systems, changes in the user interface standards and so on. So basically, what you have when you use commercial systems is a platform platforms that are stable and quite usable. What that means for you, though, is that your technical requirements for doing research using these kinds of commercial tools are pretty low, right? You might need to be able to configure surveys in something like Qualtrics, schedule text messages if you're using a system like bulk SMS or TextMagic. You might need to be able to download data from application programming interfaces that these companies provide. So if you're using Fitbit data, for example, you might write a script, a Python script or something like that to pull the data that you need to analyze the data for your participants. And they tend to be really cost effective, right? Because a lot of these systems are either free or they have very, very low, comparatively speaking, per user fees. As well as that bulk access to APIs for most of these systems is relatively low. So if you're able to combine something into an intervention or an assessment platform that makes sense for your scientific needs, using commercial software and hardware can be quite cost effective. But there are also a lot of disadvantages as well. So one is that you have very little control over the update schedule. And so what the software is actually, how the software is going to be changing over time. So there was a horror story that a team from Drexel had with using Weight Watchers app in one of their trials, where halfway through this massive RCT of about 600 people, Weight Watchers completely changed their application. They got rid of the points that were being used prior to that. And so a lot of the intervention pieces that were depending on how Weight Watchers app worked up to that point were completely scrapped, right? And so this is an extreme case, but like, you know, I use Fitbit in a lot of my work just because it's a relatively good sensor with a rich API. And the Fitbit app changes all the time as well, right? And so some of those changes are more subtle, others are bigger, and then we have to sort of re-instruct our participants where to find certain functionality and so on. But typically, as a sort of end user of these systems, right, you have no control over how they're being developed and where they're going to go next. The other piece of this is, of course, that the functionality that these commercial systems have might not be the actual exact functionality you need, right? So that means that there might be some features that are missing, right? So Qualtrics still doesn't have any kind of sophisticated sensor-based triggering for the questionnaires. So if you need to do things like send someone a survey after you detect that they could be walking for 2 hours or something like that, right? You have no way of doing that. And even the intervention features that you have available to you might not be a really good match for what you're trying to study, right? So Garmin, for example, as part of all of their watches, has this adaptive step goal where the goal goes up and down based on your recent performance, right? But that might not be the actual algorithm that you're interested in. You might be interested in having a different kind of adaptive step goal that you want to study. And there are many examples like that. So Fitbit, for example, has a little notification to disrupt extended periods of sitting. But then again, the decision rules for that might not be the ones that you choose yourself. Right, so you often have to live with these kinds of limitations that the platforms that you're using provide. In terms of the participant experience for all of this, often using commercial systems means that you have to sort of cobble a platform together from multiple systems, means that the complexity that your users are going to experience is going to be higher, right? So that means both that they will have to use multiple apps often, and that often there might be some duplication between functionality across different apps. So in a lot of studies that I was working on while I was at Kaiser, for example, we would want to use both the Fitbit to do physical activity monitoring as well as MyFitnessPal for doing diet monitoring, because the diet monitoring MyFitnessPal is quite good, right? The problem, of course, is that both of these apps contain both ability to track activity and to do diet tracking. And so it could be confusing to users which one they were supposed to use for what. And then one thing that is the case for most of these platforms is that you get very little information about the technical details, right? So, you know, for any of the activity tracker systems, whether it's a Garmin or Fitbit or so on, they all have different ways of counting steps, different ways of assessing how many minutes of active time a person has had, and you have no access to any of those classification algorithms. So you have no idea what is happening on that side. For the systems that provide the recommendations of different and suggestions, again, sort of the AI systems that then underlie those recommendations are completely a black box to you as an end user. So it can be frustrating that you can be sort of not getting the behavior that you're expecting, but you have no way of telling why that is the case. And then on the data analysis side, they're off, you know, if you're using different systems, that means that the data will be living in different places, like, you know, the Fitbit server and the MyFitnessPal server and so on, Qualtrics, and you need some way of aggregating all of that data into a coherent data set that you can analyze, and that can be pretty laborious. And often, again, since these are actual commercial systems that are often intended for sort of regular people, for end users, they're not built to support any kind of sophisticated experimentation, right? So if you need micro-randomization, or if you need something, you know, if you want to do a factorial experiment or something like that, it's really hard to do that because you can't just turn features on and off, right? And what you see is what you get, and basically when you give a system to a user, they're going to be using whatever is packaged in that system as it comes from the factory. So a slightly different approach then to try to deal with some of these limitations is what I've been thinking of as white label solutions, which is basically these research platforms that are developed specifically to help often behavioral science researchers, but others as well, run studies on in sort of behavioral and population sciences. And there are a number of platforms of this sort. Here are some of the examples. Care Evolution is a company here out of Ann Arbor that has a system called RK Studio that allows creation of pretty sophisticated, both survey-based systems as well as a little bit of intervention work. Fitabase is based out in San Diego. That they originally were mostly focused on sort of aggregation of sensor data, so Fitbit data, Garmin data, that kind of stuff. But they're expanding into more EMA space as well, mostly on the watch. And then Pillar Health is another company that also started as an EMA platform, but has since then extended as well. And what is sort of a common to all of these platforms is that they're sort of, you have a lot of off-the-shelf tools that you can use to configure a assessment tool or an intervention, but also the companies will happily do custom work for you. So they will build some custom code to extend their off-the-shelf functionality to actually get you closer to what you need at the cost, of course. And so what can this look like? Well, it can actually be pretty sophisticated. So one of the examples of a use of a white label solution is a project called My BP, My Life that is out of a Wired Health Center here at Michigan, which is both a combination of a physical activity and a low sodium diet intervention for patients with hypertension. And the whole thing is built on top of Care Evolution's RK Studio platform. It uses commercial sensors for tracking, so to either an Apple Watch or a Fitbit Versa. It integrates with patients' Epic charts. It gives participants Omron blood pressure monitors that they use to measure their blood pressure. And then all of the intervention delivery is really sent via push notifications through the My Data Help app, which is the mobile app that Care Evolution's platform uses. And as you see here in the screenshot, it can actually be made to look pretty nice, right? The issue here is twofold. One is that it is still fundamentally an EMA platform. So basically any intervention that is sent still basically has to act as a survey. So some of those surveys give no questions, so you can send people notifications with messages for, let's say, motivational messages. But the whole platform is first and foremost set up to support the provision of surveys based on various kinds of sensor data. And so you need to be able to sort of put your intervention into a form that allows that kind of the survey functionality to be used for provision of interventions. But if you're able to do that, you can end up with something that is pretty sophisticated and where all of the sensor data is gathered in the same platform. So Care Evolution has connections both with Fitbit and Apple Watch, as well as it's able to pull data from the cuffs, Omron cuffs, so that all of the sensor data ends up being in the same place as people's information about intervention use. Another version of this is a dietary adherence intervention that was built by Stephanie Goldstein at Brown. The intervention itself was built on top of Pillar Health, and it uses both EMAs as well as custom algorithms that her team developed to predict dietary lapses that then Pillar Health sort of incorporated into the platform for them. And it's able to send micro-randomized adherence prompts via SMS, right? So that you have this sort of platform that is a core of it. It used some additional algorithms that the company was able to incorporate into their off-the-shelf tools to enable Stephanie's study. And then they were also, since they have some experimentation built in, they were able to micro-randomize prompts using text messages. So what does this end up looking like? Well, in terms of advantages, just like with commercial software, these white label systems are going to be professionally written and maintained. So again, things like updates for operating system changes, for UI changes, all of that is handled for you. The other thing that you typically get is you get a much more responsive technical support, right? Because their business model is to serve you as researchers in running your studies. So that all of these companies tend to be quite responsive in sort of for bug reports or making changes that need to be made to make sure that your study is working the way that it was intended. And you end up having a lot more control over the overall user experience. And that is really a key one, that because you're able to combine the functionality that they already have off the shelf, as well as custom code, you can often end up creating a system that works and looks to your participants exactly the way that you want to do it. Now, the downside, of course, is that the more custom code you need, the higher the price for all of this is going to be. So these kinds of systems are really reasonable in terms of price for if you're using mostly off-the-shelf tools and then it can sort of quickly become more expensive as if you need a lot of custom code written. And then the other big part that is really important here is that all of these platforms have excellent study monitoring dashboards. Like this is one of the key things that they sell, is that you're able to sort of track adherence, look at percent, how the interventions are being delivered and all of that. So the reporting and dashboarding is really excellent here, probably the best of all of the versions that you might do. It looks like there is a question in the chat, so let me see here. From wearable instead of periodic syncing. So I think, and I'll be coming back to this, Heather, but the short answer is that none of the platforms that are server-based, whether it's a white label platform, whether it's your own server, is able to deal with really true real-time data, because most of the sensors that you would use for capturing something like heart rate data, something like a Fitbit watch or a Garmin watch, actually have to sync that data through the phone to get it up to any of the servers, whether it's a white label server like Fitabase or whether it's your own server, and that process has a delay, often a pretty significant delay. Right. So the only way to actually deal with real-time data for something like heart rate is to actually write the code that runs directly on the watch. And so if you have a watch, and so you can have an application that runs on the watch that has immediate access to the sensors, then you're fine. But as long as it has to go through the servers, it ends up being a pretty significant delay to when you get that information. Also, again, please unmute yourself and ask a question when you need to ask a question, because it's hard for me to monitor chat on a small laptop. All right. In terms of disadvantages of white label solutions, one is that UX experience may still be suboptimal, right? Often these things are all, in fact, pretty much every one of the platforms that I know of started as a data collection platform. And so often you're trying to sort of cram an intervention into something that was initially a data collection platform for observational studies, and that can have suboptimal results. There also the fact that often these things are built by relatively small companies. Some of them have good designers, like Fitabase is a really good example of that. Others not so much. So the overall user experience might be a little bit less optimal than what you would like. But the other thing that is really sort of important to note about these white label solutions is that your project needs to fit the overall features of the platform, right? You can get custom code written to extend the stuff that they already have, but those extensions are going to be reasonably limited, right? So if a particular platform has no sensing, it's going to be really hard for them to build that out for you, right? It's because often they have no sensing because they've decided that that's not where they want to go, right? And so you're not going to be able to, it would be way too much work for them, and work that they're not able to then use for other clients to build out the kind of intervention that is just not part of their core platform, right? And so that's a piece of it. And a prime example for something like this is in the case of Fitabase. Fitabase has no interest in having a mobile app. They've made this choice very consciously for really good business reasons. So if you need a mobile app, like Fitabase is not the right platform for you, right? Because they would be happy to help you to deliver interventions onto the watch, but they're not interested in actually maintaining a cross-platform mobile app, and so that's not going to be a kind of a sort of custom development that you can ask them to do. It would just not be a good match. So you would need to go with a different company for something like that. And so the sort of big picture here is that really the project needs to fit pretty closely to what the direction of the platform is. And then, because really the way that these companies work is that they try to optimize for how much code that they write can be reused across different clients that they have, right? So if they do some custom development for you, they would prefer to do the custom development that can then be turned around and incorporated into the core platform, so they can provide that to other clients too, right? So that all of that means that they're going to be sort of optimizing for the overall direction of where they want to take the platform, and so the amount of truly novel custom code that is not just sort of a small extension to what they want to do is going to be difficult to do. And then often they don't have a sophisticated engines for doing experimentation. So for things like factorial experiments, micro-randomized trials, and or things of that sort, although that is starting to change. So I think for certainly Fitabase and Care Evolution, they're starting to support a lot more of that kind of experimentation. So, and other than, let me just actually pause for a second. Any other questions about this before we move to hybrid solutions? Nope. Okay.
I have a question. I have a question. Can you give an idea of the cost with maybe just even a range, the cost with
a really good question. So it varies widely. And from actually being completely free, so Care Evolution, for example, if you have up to 100 users in your study, so up to 100 participants, and you only use their off-the-shelf solution, so they don't need to do any programming for you, that's completely free. You can run as many pilot studies as you want, up to 100 people, and it's going to be free. Fitabase has what they're calling a small pilot program, which I don't know exactly how it's set up. It's something also in the neighborhood of 100 people that is about $2,000. That is relatively cheap. Now, if you want custom code built, and that can go into the tens of thousands of dollars very quickly. And so it really depends on how much you can get away with the pieces that they already have built out, right? Versus how much you need them to add to that. And so the range is truly massive, right? So we've had projects with, let's say, Fitabase where the $2,000 pilot program was all we needed. And in fact, a former student of mine is now running a study on Care Evolution that's going to be completely free, right? But we've also, we're currently doing a project with Fitabase where I think it's something like, close to $200,000 that the total cost is going to be across all of the development that they need to do for us. It's just because there is a lot of new stuff that they have to build, right? And so it can be non-trivially expensive, right? And so depending on what you need. And so it often might be actually easier to build something yourself if you have a programmer who can, or cheaper to build something yourself, unless you need really robust functionality and scale. And that would be one of the other advantages of all of these commercial systems, whether it's commercial software or white label, is that if you need to scale up to do really large study, doing your own custom code is just not a great way to go. And I've been bitten by that more times than I want to recount. But so it really depends. Does that answer your question?
Yes, that does. Thank you so much.
One question I had,
go for it.
Just random. One issue that I've run into with commercial software is like my university won't contract with any sort of software that's not US based because of legal reasons in case they have to enter into a lawsuit. And so I wondered like how other institutions sort of manage that, or if that's
so. It depends on the kind of institution. Healthcare organizations tend to be a lot more conservative than universities, but even with universities, as they've gotten more sophisticated in terms of how they understand where how the data is being used, there are more hoops to jump through. I would say that well, there are a couple of considerations. One, it's not just commercial versus not, right? Because even if you're building your own system, the data is going to be living either in Amazon Web Services or Google Cloud or something like that, right? And so you have some of the same issues are present there as well, right? The question is just, whether you actually need the system to be HIPAA adherent, compliant. If so, whether whichever organization you're going with has the ability to sign those business use agreements, right? Whether both the platform itself is actually HIPAA compliant, but also even if it is, if they're not, if your institution does not have a contract with that institution to sign the business use agreement, that doesn't do you much good, right? So I had an issue with this while I was at Kaiser, where Google platform is very much HIPAA compliant, but KP did not have a relationship with Google where they were able to sign those documents, and so it was a massive headache, right? And so I think that a lot of this is from the regulatory perspective getting more complicated. I think what I'm seeing at a lot of universities is that there a lot of these negotiations are actually have been done upfront now. So Michigan, for example, now has both Google and Amazon, all of these things already in place. Like so if I'm building a new tool and my data is going to be stored in Amazon on Amazon Web Services, that is totally fine. Like I don't need to jump through any additional hoops. But if I want, for example, Garmin to my data to be stored on Garmin servers. The medical school IRB is going to want to try, will be asking a lot of questions, like is there going to be identifiable data and so on, and then it might get a lot more complicated. The nice thing about all of these white label solutions is they know who their audience is, right? So they themselves usually have HIPAA compliant stuff already taken care of, but again, your institution needs to be able to sign those documents with them, and if they're able to do that, then you're in a clear. Cool. Any other questions, guys? All right. So the next class, the next thing that you can do is what I'm referring to as hybrid solutions, which is basically to combine either white label system or a commercial system with some code that you yourself write for whichever reason. All right. And so a couple of examples of this, a new PhD student that Mark Newman and I are co-advising here at Michigan has this project now called Walk to Joy, which is intended to help people develop positive associations with physical activity. And what we're doing is we're basically, we're giving people Fitbits to do activity tracking. We're sending all interventions via straightforward SMS and doing assessments through Qualtrics surveys. But the actual sending is all done on a custom survey that we ourselves wrote, on a server that we wrote, right? So the server is managing randomizations. It's sending messages through the Twilio API. It's sending people messages with links to the right Qualtrics surveys and so on. And the reason we wanted to do this is to be able to send these little cute MMS messages of animated GIFs. So there's a little rat running a wheel. She has a little walking penguins that are cute. And so we're basically trying to see, like, if you get someone to smile because they're getting a cute GIF, right? As you're giving them information about physical activity, would that change how they think about physical activity, right? So the server has basically the users don't interact with the server at all past the time that they authenticate their Fitbit with our server. So it's done at intake, and they never touch our server again. Their experience is now completely on the phone via text messages, right? And then clicking on the survey links from text messages to open them in Qualtrics on their phone. But most of this stuff is the actual business logic is actually being done on our server. And so how these things are getting randomized, who is getting what, when, all of that is handled by the server that we wrote. A similar version to that was a system I developed while I was at Kaiser called BerryFit, which was a lifestyle change intervention for patients after bariatric surgery. And what the way the BerryFit worked is that, again, we would sort of give people commercial devices. So they had Fitbits and they had the breathing scales to connect to Fitbit app that also connected to the Fitbit app. We would send them things via text messages, like waiting reminders and personalized food advice and so on. But again, there was a backend server that managed all of the randomizations. So we were able to do a combination of a factorial experiment and a micro-randomized trial all in a single study, because we had full control over the randomization, right? And so if you need that kind of control over the experimental design that goes beyond what a lot of these other solutions have, you might actually need to build some custom code. And so the advantages of that is that the polish and usability, you still get the polish and usability of the commercial components, right? And then you can focus your resources on the pieces that are really new, where the sort of the crux of your science and your study. So I do a lot of work in physical activity, and there are a whole set of components like self-monitoring that you always have to have. Like you would never have a physical activity intervention that does not give people some feedback on the activity and provide them with some graphs of the history and things of that sort. It's nice not to have to redevelop that a million times, right? And so if you use something like Fitbit, you can actually just use that functionality in their app, and then layer on top of that other features that are actually more interesting to you scientifically. And often you can actually even integrate some of those features via their API. So for example, now the Fitbit has an API that allows you to change their goal people's goal programmatically. So we could do things like experiment with different kinds of adaptive goal strategies, where the goal itself would be pushed into the Fitbit system for each participant, and so all of the then standard Fitbit functionality, like acknowledging that the goal was met, and all of that stuff would happen automatically through Fitbit without us having to do anything else. And then that allows you to also have a more sophisticated intervention with few resources, right? If you can leverage a lot of this commercial stuff, then the little that you have, especially for something like a pilot study, you can really focus on adding pieces that are going to be novel and that will allow you to flesh out what that intervention is going to be. And then for, in a lot of contexts like a health system, going this kind of route might actually be an easier sell, right? So in the case of VeriFit, we could basically use text messages with KP policy already allowed, right? Without giving people additional the mobile interventions that we developed that we would have to go through a whole bunch of layers of approval before they would even let us do a small pilot study. And then again, in terms of thinking methodologically, one of the key advantages of this kind of approach is this flexibility with how you actually do your experimental design. You can combine factorial experiments, micro-randomized trials, smarts, whatever makes sense, right? RCTs, to actually do the study that you think needs to be done. And that often goes beyond what any kind of commercial platform is going to be able to give you off the shelf. In terms of disadvantages, you're still developing software, which means that both the time and complexity of the development can be pretty high, right? That kind of integration between your own pieces and commercial stuff can also be suboptimal, right? So for example, if you're interested in having a system that focuses on minutes of moderate to vigorous activity, for which Fitbit has an internal metric called active zone minutes, right? Those minutes are not actually provided via the API, so you can't get to them, right? So the people see them on their phones, they see them on their watches, but you as a researcher are not actually able to get them out of the system, so it's sort of hard to use those minutes then to provide tailored interventions. And then, often this depending on where things are connected, you end up with user experience that's not really brilliant. So when we did this VeriFit project, for example, Fitbit did not allow us to change goals inside the Fitbit platform programmatically. So this predates that change, which meant that every day we would send people a custom step goal for that day, and that goal would come through a text message. But their Fitbit device would have a different goal, and they would sort of have to manage the cognitive complexity of knowing that the goal that they're actually trying to reach is the one that was in the text message, and not the one that their watch is telling them that they should be reaching. And so this kind of stuff, the connections can be a little bit funky. So Arjun has a question: which of these systems have allowed for real-time interventions, and what are the programming complexities? So it really depends on what you mean by real-time. If you really mean real-time, like in the case of Fitbit, right, having the up to the minute step count and heart rate, again, the way to do this is to actually have code running on the watch itself. Right, so you're if you're able to run the code, if you're in the case of a Fitbit, you would create something called a watch face, a custom watch face that would be monitoring all of these sensor data, and then would be, you could be prompting people with messages. The development is really going to depend on the platform, but often any code that you actually develop for a watch or any kind of other sensor system, that the development environment is going to be a lot less feature rich than if you're doing something on the phone. And so it really depends on how real-time something needs to be. On the other hand, if you're using a sensor that is already built into the phone, and it's often possible to do something that is reasonable in real time. So, if you need to do geofencing, for example, you can get almost real-time GPS data and incorporate it in your application on the phone and do a trigger off of that just fine. And so in both cases, you will need to do likely need to do some custom code. Although if it's completely phone-based, there's some other ways of doing sort of automation using, for example, something like shortcuts on iOS. So it really depends. But the more real-time your system needs to be, typically the higher the development requirements. I think that's sort of a fair way to think about it. If you can do something daily, right? If you're only sucking all of the data in every night, doing all of your computation on that, and then making changes for the next day, that is substantially easier to pull off on a consistent basis than something where you need, your step count to be accurate up to a minute. And then finally, this is the way that we often think about mobile health, which is that we build our own solutions from the beginning. That is certainly a sort of most direct way to get exactly what you want. If you have the resources, if you have the expertise to actually build a solution, you can exactly specify what interventions you want. You can collect the data and exactly the data that you want. And so it allows you to really have extremely good control over exactly both the user experience and what kind of data is being generated through these interventions and assessment platforms. What's also nice about building your own code is that you're able to, in a much more thoughtful way, balance your scientific requirements with different kinds of burden, including privacy on the users, right? So you can always make a sort of you can always make decisions about how much of raw data do you save versus high-level inferences. Like that's a prime place where a lot of these trade-offs come into place. So that, for example, GPS can be highly invasive. And for some of the systems that we've built, we've had the GPS running every 5 minutes on someone, right, for a year. And so the question is like, what do you actually save? Do you save the raw coordinates? Or do you just really, the thing that you care about is some rough classification of where the person is? Are they at home? Are they at work? Are they at the bar, right? If that's the level at which your science is actually asking questions, you can often do that kind of inference on the fly and just save the label, right? And get rid of the coordinates. They're not actually tracking people, for at that kind of really in that kind of invasive way. And so you can make those kinds of decisions when you're doing your custom software, which is often less possible when you're using off-the-shelf tools. You can also do much more customized timing of self-report prompts, right? If you're controlling the sensors that your system is using, you can have very, very sophisticated ways of assessing what the state of the user is, and then to ask questions based on that, including things like assessing whether someone is interruptible or not. And this is really important when you're collaborating with engineers and computer scientists. What's nice about custom software is that you can typically have a much more significant component where the engineering itself is a contribution, right? New algorithms, new interaction techniques, custom devices, right? New sensors and things of that sort. Like you can incorporate those into custom code much more easily than you can into if the rest of the solution is off-the-shelf components like commercial software. And then, of course, you have full control over how randomization is done, so you can do highly complex experimental designs. The disadvantages, of course, is that the complexity is really, really high. And this is, I've been doing this for 15 years. I've been building these systems for 15 years, and I'm always surprised to this day how long it takes and how much more buggy and how much more difficult it is than we think. Like, I always estimate it's going to take us twice as much time as I think it will. It takes at least 4 times as much time. And we end up with way more bugs than we think, regardless of how much testing we do. And that's I think a really key piece to know here is that it's going to be expensive, however you do it, whether you do it with your own programmers, whether you outsource it, there are going to be bugs. And because the quality of the code ends up often being lower than what you would get by using commercial software, right? Because code is either written by students or individual programmers, staff programmers, so there's a lot less code review, right? And there's also just a lot less emphasis on formal testing because all of that requires time and resources. Now, the thing to remember is that dependence on third-party code is still present. Like, you don't get rid of this by building your own code because you're always building on top of a whole bunch of layers of code that other people have written. These are libraries, right, for different tasks that you need to do in your code. You're also often building, your code is going to be running on top of a mobile operating system. It's going to be using commercial sensors and so on. And so some of these dependencies end up propagating down to the behavior of your system, regardless of how much control you want to have over it. And then finally, sort of when resources are limited, it's always tempting to just focus on the main features that you need for your study and to sacrifice either the testing or study monitoring, so the building of all of these dashboards for doing study monitoring. And both end up being a bad idea, right? And I'm guilty of that many times over, and it's always a bad idea. And so I'll come back to that for a second. So just if you end up deciding to go this route, there are a number of sort of things to keep in mind. One is that just you have to expect that there are going to be bugs, and things are going to break even when you don't change anything. And this is incredibly frustrating, and it has happened to us time and time again, right? So an operating system update comes out and something breaks, or libraries get abandoned. One of the things that we've been dealing with over the last year, for example, in the system card steps that we developed for supporting physical activity, one of the absolutely core components in the server's end of the system is a library that schedules all the tasks, sending notifications, sending surveys, basically, updating people's Fitbit data from the Fitbit server every night and so on, like a completely core component. And we use a task manager software that is used in Python routinely. But a couple of years ago, that got abandoned. And then as other parts of the software changed, now all of a sudden this library that used to work just fine started getting really flaky. And so things like the events are being missed for no good reason. We didn't change anything on that side. But the server infrastructure changed, some of the code around it changed, and all of a sudden something that was working just fine stops working. And it's incredibly frustrating, but it happens every time. APIs will change. So at one of the first studies that they did in mobile health, we had a Google Maps component inside the application to help people basically select where they work and live. And halfway through the onboarding of our new participant cohort, Google changed something, and that just started crashing the application. We didn't change anything, and something, after months and months of testing, something that was working just fine, all of a sudden is breaking, right? And our programmer ended up spending 48 hours with no sleep trying to figure out what happened and how to fix it. When you're working with a third-party company, you just yell at them, right? And then they fix it, right? So if you're working with Fitabase or something like that, and something is breaking, you get on the phone, and then it's their problem, right? It's not your problem. Here, everything's your problem. And so that has to be sort of kept in mind. And then there are all kinds of other small things, like often you have a number of certificates that are required for any kind of mobile software to run. These things expire, you forget to update them, and then all of a sudden things are breaking down. And then finally, and this is really apropos this question about real-time sensor data. Often, if your sensor data is going through the phone, you actually have, and this is the case for any Bluetooth low energy device, right? That where it's actually the data itself is being sent to the whatever platform, whether it's your server or the vendor's own server via the phone. That process is actually completely managed by the operating system. Operating system, let's say, terminates the Fitbit app because you use Facebook too many times and the memory is low, right? And all of a sudden, the Fitbit phone watch is no longer syncing, and you have no control over that, right? Third-party APIs that might not work as intended, right? So they created this custom Fitbit watch face to basically try to get real-time step data from Fitbit watches, and it just did not work how it said it would work. Like it would work for a couple of days and it would start breaking. So a lot of these things that even for the code that you write, you end up having less control than you think, just because you have to depend on so many layers of dependencies. Now, what all of that means is that it's absolutely crucial to have many layers of testing, right? This is a standard, user experience testing. This is the kind of testing that we normally think about, where you give, your friends and family members and other research members of the app to use. Study monitoring, so using dashboards to look at adherence, to look at randomization, things like that. Automated monitoring, this is called unit testing in software development, right? And then often even what you want, although this is currently not done often, is sort of simulation testing, where you can simulate what kind of data the system would be getting and then seeing how it acts with that. And the reason you need all of these, and then it seems like there's a question, so I'll come back to that, is that each layer of testing actually misses a bunch of important things. So if you think about something like just having an app and testing it on your own phone, if some of the interventions that you're getting are getting randomized, right, and you're not always getting them, the fact that an intervention didn't come at a particular time can be either because it broke or because you were actually randomized not to receive it. Like from the user experience perspective, it's really hard to distinguish those two, right? And so you need to be able to sort of pick up on those things through other means. Often that's through sort of having dashboards that look at, you know, all the randomizations that were calculated, the decisions that were made, what was done based on that, and so on. So that ends up being really, really important. But those kind of study dashboards have the limitations as well, right? They can't tell you what exactly what kind of content someone received, whether that content was appropriate for their situation, and so on. And even things like unit testing, like that where you write explicit tests into the code so that the code doesn't compile before you actually the tests are passed. Insofar as your interventions are using contextual data, so data about the person's current situation, it's really hard to sort of know in advance what data the system will be getting, and to deal with all of those bugs up front. So a lot of this stuff ends up what it means is that you both need multiple strategies for testing, as well as that the bugs will come up even once the study is in the field, because there's, even with all of your efforts, it's still hard to catch everything. All right, there's a question here. Oh, there's just the explanation is helpful. Thanks, Heather. All right, so how do you make decisions about what to do with all of this stuff? Well, really, you need to ask yourself sort of a set of questions. One is, and I think this is really the key one, where exactly is the sort of core of your science? I think this is really a key one, right? Are you working on content? Like if you're a psychologist and you're really interested in things like how the messages, motivational messages are getting framed, right? Your science is really about those forms of communication, right? The framing of the messages, what language is being used, and so on. And it might be less important exactly whether they're delivered via, let's say, a text message or a push notification, right? Or whether they're presented with some additional imagery or not, right? And so you would make choices based on exactly the thing that you're trying to study. If you're like me, a human-computer interaction researcher, and the actual design of the system is important, then, right, yeah, I actually am pushed into doing more custom design and custom development myself, because that's the part that I'm actually trying to study. The other piece, of course, is sort of what's the stage of the research. If you're just trying to test a concept, like in that Walk to Joy study that we were just talking about a few minutes ago, it might be totally fine to just mock up an experience that is not exactly like what you're trying to go for, but that is close enough, right? So maybe sending messages via text messages is fine. Like even if you want eventually for this to be done in some other way. What kind of resources you have, right? Do you have technical expertise? Do you have a lot of money? Are you able to find people easily, right? I mean, that sort of what kind of resources you have will often push you in one direction versus another. And then finally, and I think this is really a key one, which is sort of what kind of interdisciplinary partnerships do you have? Do you have colleagues who are engineers and computer scientists who can help with some of the development or management of the development, right? Is that what you're trying to go for, or do you just need, you just need an app of some sort, and it doesn't really matter how technically sophisticated it is or what exact algorithms it uses? So all of those kinds of questions will end up pushing you in one direction or another. But as long as you know the landscape of potential options, then it's easier to make those decisions. The similar kind of stuff happens on the hardware side, right?
Excuse me. I'm sorry. Hi, can I ask a quick question?
Absolutely.
About the resources. So, and thank you for all this information. It's really helpful. So I work in a soft money environment where all the resources come from grants. And so I'm just trying to imagine, I understand the functionality piece, the timeline piece and all that, but in terms of funding, to me, it feels like it would be really hard or really tricky to write a grant where custom software is being proposed and the justification for that budget wise and the staffing and all that kind of stuff, and versus just saying, oh, we're going to take this off the shelf white label thing this platform that already exists. I wonder if you can kind of speak to in your experience or just knowledge, like where that funding can come from, and are grants a viable route to get that funding or not, maybe?
Yeah, a very, very good question. So it's complicated, right? There are few requirements both on the technology side and on the grant side, right? On the grant side, if you're going for an R01, like a trial one, R01, right? You need to have preliminary data, so you need to have some way of actually building something upfront, right? Now, that said, preliminary, you can often actually get preliminary data with a lower fidelity version of what you're trying to build, right? So you might actually be able to hack together, text messaging and commercial software to build something that resembles the experience that you want and pilot it to get pilot data, right, for a grant. So that is one option, and that can often be done pretty cheaply or for or using some internal sources of money that your organization might have. For actually building the code, R21s and R34s are an option. They're harder to get, but they do allow for technology development. And I've certainly seen at Kaiser some successful models where those grants were used to build up the code. And then that goes towards an R01. We've also seen at Kaiser where Kaiser is large, right? So they actually have a software development shop that is part of the national center. And there was one instance that I'm aware of where Jennifer McClure, a colleague of mine who works on smoking cessation, they actually managed to donate. She managed to work out with them to donate some of the time to build the initial versions of the system, so an R01 can be submitted. And then the idea was that once you get an R01, some of that would actually go back towards software development and cover some of those initial costs as well. And so people basically do all of these workarounds. The other thing to know though is that not all R01s are trial R01s, right? So depending on how you actually frame your project, it could very well be that software development is something that you can directly build into the tool. And so my first R01 had intervention development as a component, and that got funded, but it didn't go to a left, and this was for physical activity intervention. But the study section that reviewed it was an informatics study section. It was not a sort of a lifestyle or behavior change study section, right? And so knowing where you're submitting and what the sort of gestalt of those study sections is also really, really important. And so I'm currently, we have another grant going in July, and I've gone back and forth with colleagues who sit in different study sections to try to identify exactly where we might be able to pitch this, not to get into the situation that you were just describing, right? Because, and any of the clinical ones are basically, we would be dead on arrival. Just there's too much development in the grant and they would just not be able to deal with that, right? And so we're again going to one of the bioinformatics study sections because they're just that kind of sort of technology development and algorithmic development is something that is closer to how they understand the world. Does that help?
Yes, that's great. Thank you.
Mm-hmm. No problem. All right. So just finishing up, and then because you guys need to get a little bit of a break before Caleb begins. Other couple of things is right. It's really sort of when you're thinking about hardware, thinking about what is the information that you actually really need from hardware, right? Do you need real-time data? Do you need raw data, right? Or are those sort of more nice to haves and you can actually do your core science even without having those things? often what you're able to do is that you might also even consider having sort of levels of functionality where there's sort of core functionality that you can pull off with purely commercial hardware, right? That actually addresses your most important research questions, but then have sort of additional things that are sort of more nice to have side, where participants might either be able to opt into to get more intrusive sensing turned on for them, or where you would give them some additional devices that are less polished, right? And they would be willing to put up with that for whatever that extra value is that those additional questions would be driving, right? So here as well, like you actually often have quite a few choices to make in terms of both the sort of the range of data that you need to collect and exactly how granular or how raw data, whether you need raw data at all, that would direct your hardware decisions. So just to conclude here, like any of these choices come with trade-offs. There's just no free lunch here. And really those choices need to be driven by your understanding of where your core science is, your expertise, as well as the resources as we were just discussing. But regardless of what the direction you decide to go, all of these studies are increasingly getting more and more complicated and more sophisticated, which means that there are going to be bugs even after extensive testing. One interesting way to sort of think about this is that what may be a bug for me as someone who develops interventions is actually someone else's science. In this particular case, Walter Dempsey is going to be talking to you this afternoon about data missingness, right? For me, data missingness is a problem, right? I want complete data as someone who develops interventions. For Walter, that's where interesting statistics gets developed, right? So you might be able to actually try to preempt some of these complexities and bugs by really having partnerships where the issues that might come up become part of what is actually being studied. And that can make both the project more interesting, as well as sort of cut down on some of the lots of the frustrations that happen as part of developing this kind of work. And so often it's sort of said that when you're building any kind of a complex system, you can make it good, fast, or cheap, and that you need to pick two, but you can never have all three of them. With mHealth, increasingly, I've been thinking that even if you get one, you're doing really well. But hopefully, as this sort of field matures, we'll move closer to where other engineering is, where you can truly start having two. You're never going to have all three, and I think that's really important to know upfront. So I'll stop there because I think we still might have a few questions a few minutes for questions if anyone has any additional ones.
I had a quick question, if that's okay. Well, maybe it's not a quick question. As someone who does a lot of this work, do you have kind of like a go-to developer that you work with? And if so, how did you find them? How do you do that?
No, unfortunately, it's been a constant struggle, right? We've used students, we've used contract programmers, and I think it's still not clear to me that there is a optimal model for developing custom software, right? And so with that also, there are all kinds of trade-offs. Students can be quite good, but they tend to write more hacky code that is less well documented. They also leave, especially if you're using something like master students. You often have them for a year and then they disappear. Staff programmers are adults, right? You can have them for a longer period of time, but supporting a staff programmer is not trivial, right? I mean, you're looking at $100,000+ a year salary plus benefits, and so you need to have a large enough portfolio of grant funding to be able to support a person like that, or go in with other people, right? And where you can sort of share resources. Right now, I happen to have enough grant funding to sort of jumpstart the development of the next version of this intervention platform that we've been working on, because our old one, the SCARTSEP system, at this point, the current code is close to 5 years old, and it's just breaking at the edges, and we need to redo it. But what we're trying to do is actually combine resources of a couple of new centers here at Michigan. One that Billy Nahum-Shani just got at ISR, and this Wardell Center that I was mentioning, and where we can sort of pool resources to build up a software development group that can sort of, and then everyone will be able to use the same platform. That's the sort of what we're going for. The one interesting twist that I heard about recently, that one of our tech transfer people told us about, is that sometimes it's possible to find a professional software development firm that is interested in having sort of a longer term relationship with you, rather than just building a single system. And where you can sort of, if there is a trajectory of work where there would be sort of multiple projects that would be building off of the same code base, right? You might be able to actually sort of set up a system where each grant that you write has a chunk of money that goes towards that company, right? And then they sort of take ownership of building and maintaining that code for you long term. But you at the university actually keep the IP. I think that's actually a really interesting setup here, where there's still sort of grants for hire in many ways. But the idea is that it works, you know, they have a reasonable income stream that is going to be coming for an extended period of time. And you have adults building high quality code, right? And so I think there are various kinds of models that are possible. I think it really depends on sort of where you're sitting, where your resources might be, right? If you're in a computer science department, finding students is the easiest way of going about doing this, right? If you're sitting in the medical school, you have less access to highly technical students, and you might need to actually do something else. But you also might have larger grants than someone who will be sitting in a CS department, right? And so it's always this kind of a balancing game of trying to find the least bad solution given what your current resources are.
I have a question. Sorry, I'm calling in from Qatar airport, so I don't know if you can hear me okay.
No problem. Yes.
On my way to Australia. So I wanted to ask about the end of the commercialization process. So I've been developing some custom app, and we're about 75% through. We'll be doing a randomized control trial next year. After that, so we obviously this is a pilot study, so we want to do a more full scale study. But after that whole process, we want to we want to maintain this. We want to have this app be publicly available. But have you got any advice about in terms of like how to do that? You know, the patenting or commercialization, or what kinds of things should I be thinking of for the future?
No, that's a really good question. It's like the basic options on the table are, you either spin out a startup of some sort, right, from it if there is some potential for that, and often that you can do that through the university, where they will handle a lot of this kind of tech transfer process. You try to use the system for other projects like that. That is often, so if you want to stay strictly on the science side and running a company is not what you're after, right? Then one of the nice things about having built something for one project is that it becomes a huge leg up for getting the next grant, right? So if you're able to sort of line up a set of grants, each one of which would have some resources for sort of further maintaining the platform, that can be really compelling way of going about doing this, right? And so that's part of what we've done with Cart Steps, is that we basically, I think it's on grant number 4 that funded this in one form or another. None of them sufficiently, unfortunately, right? So we didn't, and so part of it, for me, it was a learning process of just how much it costs to even do that, right? But if you can do that smartly, where you can make sure that each grant has some long-term funding for supporting of the platform, you can actually keep things running for extended periods of time. That said, one of the things to really understand is that any software will rot. Like the code rot, notion of code rot is real, right? So even if you actually bug fixing and sort of keeping things moving, the servers are still running, eventually things end up needing to be rewritten. And so it's not it, and often it's really that kind of those points where things have to be rewritten are the places where this kind of a model that I was just talking about breaks, right? Because that cost then becomes much closer to what the initial cost of developing it in the first place was, right? And so yeah, the other option that I've seen people do is licensing, right? But but often that is a lot easier for very specific things like an algorithm for analyzing MRI images or something like that, right? Where that thing is a standalone chunk of functionality that can be licensed to others versus a full mobile health intervention. That is harder to license to other parties. Yeah, unfortunately, I wish I had a model that I can tell you works really, really well across the board, but I'm not aware of one.
Okay, thank you. That's really helpful.
Sure. I know we're past the time, so I want to give you guys 15 minutes to stretch and get coffee or whatever, and then Kellen will be joining us in 15 minutes to talk about network analysis. I'm really looking forward to hearing that. So we'll see you guys at 12:30 Eastern, 9:30 Pacific, or wherever else you are. See you soon.